Welcome to Better Together, looking at integration in the lab. Welcome to Daniel from Wega.
Thank you.
And we'll take a look at standards. And today we're going to talk about SiLA. SiLA, a communication standard in the lab world. So what is SiLA all about, Daniel?
SiLA is really about communication in a lab between different systems that you usually have in a lab, like limb systems, balances, instruments, etc. It's really all about communication and all about enabling this communication and make it happen that you really interoperate with these different systems in a nicely and integrated way.
So I hear that SiLA started in the high throughput automation world and has now made the transformation to become much, much broader, also cover typical instrument integration scenarios that you see in the analytical lab, in the process lab. How is SiLA doing that? Are there fundamental technology differences, or is that all based on one common layer?
It's all based on one common layer, and basically you're right, SiLA started in this high throughput experimentation area where you really had these monolithic systems where you had to integrate many different devices into, let's say, a master workflow kind of thing. And with the new SiLA, you basically we extended that so that it's not only about this type of like interoperability between instruments. It's really about services. In the end, we consider everything as a service, being it a lab instrument, being it a LIMS or an ELN in your lab. And SiLA enables that these systems interact with each other, that these systems find each other and discover what the capabilities are and basically how communication can take place. It's kind of like a common language, yeah, in natural speaking, so you understand each other, okay, and you have a common vocabulary that you share. And so therefore, you enable the seamless communication between the systems in the lab.
So I could, if I understand correctly, I could then say, I have systems that I want to talk. So I have a LIMS and I want to send sample lists to a chromatography data system. Or I have a high throughput screening platform and I want to instruct my liquid handler what to do and talk to the plate reader at the same time. Or I have an ELN and I want to connect it to a balance. So those would all be use cases that I could use the same technology for.
Right, right. And we are really trying to apply industry best practices. Maybe you've heard of like smart industries, smart factories, Internet of Things, Industry 4.0, which is very common, I think, in the European area as a term. And we really kind of use these best practices and apply the required level of like life science on top of that, so that we enable this seamless integration and interoperability between these services.
And it seems with SiLA too that is becoming more and more the focus to go onto those standard protocols, standard platforms to make it really accessible, easy to use, easy to implement, and to not invent new things and not to lock in people into specific frameworks and platforms and protocols, so that it becomes accessible.
And you can see that in a really growing ecosystem, in a growing community of people who use it, who basically work with the standard and also feedback into the standard and help the standard grow. And I think this is the right way to go. It's really about a common approach and not kind of creating this locked-in type of small ecosystems, but really creating an open ecosystem which solves a common problem that many, many labs have in nowadays.
Wonderful. So you talked earlier about having a common language, having a common vocabulary, and talking about certain things in a certain way. And I understand SiLA has this notion of features that help us capture that. Can you talk about that a little bit?
I think this is one of the great concepts, really, that makes SiLA really unique. So all these capabilities I mentioned before, you describe them using so-called feature definitions. And a feature definition, you can imagine like a glue or something that builds the bridge between an IT, a more technical, and the life science world. It really translates between the two worlds. And maybe if you're familiar in a regulated environment where you have to interface instruments, for instance, to a LIMS, you usually have to write complex specifications, functional specifications to describe these interfaces so then that you are able to validate them afterwards. And the feature definition language provides you a standardized way to create these feature definitions, and they're human as well as machine readable. So we basically solve two things on one spot, and you directly have a specification for your technical folks to implement that, but you also have like a functional specification you can use for your validation of your interfaces in one go. And this is the great thing. And then another great thing on top is, of course, feature definitions can also be reused. Right? It's not something you create for your specific one interface, but feature definitions for interfacing LIMS with chromatography data systems, for instance, can be reused. Okay, so there's a big, big value in your project.
Okay, so the feature definition is basically a set of related commands, and the feature definition tells me, okay, what commands are available for this particular functionality. How do I call them? What are the parameters? What can I expect back? And that allows me to then also learn by looking at an instrument, talking to it, what are the commands that you support, grouped by the features that it might actually be implementing, right?
Exactly, and usually, I mean, in your labs, you do have to execute workflows, and these feature definitions, of course, greatly help you to orchestrate your workflows, because you know what you can do, what you can expect, and how you have to talk to these different services.
So we'll have another video around feature definitions and how they work in more detail in the series. So we have a link in the video description.
Right.
Let's look at one other issue, which is, there are a couple of standards out there. So what is SiLA doing about the data side, right? Because I hear about the communication. Do you have a data format?
Especially if you look into analytic data and more complex data, SiLA has a very strong collaboration with NML, which is an ASTM standard which describes the data. I think we have other videos in the series who basically describe that in more detail. But in the end, the feature definition, of course, not only describes the interaction model, but it also describes the data. But it doesn't reinvent the wheel, and we use, of course, existing standard data formats like Animal to do that. Okay. It would be stupid if we not use what is existing already and what is proven to work.
Okay, so that means that I really have an ecosystem, SiLA taking care of the communication bit, Animal taking the data part, and the two communities are also working together, right? We have a lot of overlap between...
There's strong interactions.
Yes, yes. Okay, great. So thank you so much for that, Daniel. Very interesting.
Thank you. Thank you, Burkhard. It was a pleasure.